This is a video live WebEx over lessons 13 and 14. And for lesson 13, I'm going to start talking about factoring by grouping. I discussed how to find or factor a GCF out in class, but if you have any questions about that concept, just email me, please. Factor by grouping. The magic number of terms required is 4. So to factor by grouping, these are the steps. You group the terms with common factors. In other words, you group the first two terms and the last two terms together. Step 2, take out the GCF or greatest common factor from each group. Step 3, it says factor the common factor from each expression. That just means whatever's in each parentheses, you take out that particular binomial. And then step 4 is not required, but highly encouraged. Check your answer by multiplying everything out. So I have 3 examples I want to go over with y'all. First example to the left, we have 4 terms, so we need to factor by grouping. So let's group the first 2 terms and the last 2 terms together and take out each GCF. First pair of terms, they have the letter P as in Paul in common. Now, when you take out the letter P from each of the first 2 terms, you have to write what's left in the parentheses. So what remains is Q minus 10. The last 2 terms share an 8 in common, so we pull the 8 out. And when we divide each term by 8, we're also left with Q minus 10. Now, that's a great sign that you get the same binomial in each pair of parentheses. Technically, that Q minus 10 is another GCF. So we can take out Q minus 10 from both terms. Now, when we take a Q minus 10 out of the first term, what's left is P, the letter P. And when we pull out a Q minus 10 out of the second term, what's left is a positive 8. And our answer is factored completely. Let's look at the second example in the middle. Again, we got 4 terms, so we factor by grouping. We'll group the first 2 terms and the last 2 terms and take out each GCF. For the first pair of terms, 9 and 12 are divisible by 3. And remember, when you pull out or trying to find the GCF among common letters, you always take out the smallest exponent. So for the first 2 terms, that's the letter P. Now we need to write what's left over in parentheses. This step is not required, but it helps. Just divide each of your terms by your GCF. So 3 can go on to 9 3 times. P squared divided by P, we're taking one P out of that, left with just letter P. 3 can go into 12 4 times. And actually, for the second part, the P's cancel. Now, before we pull out the GCF among the last two terms, look at the sign of your last term. It's negative, but we need it to be positive to match the sign in our parentheses. So to change a sign, you pull out a negative GCF. So that's just -5. Now, when we pull out a -5 out of each term, signs will change for each term. So a -5 going into -15p, that's a positive 3p. And -20 divided by -5 is a positive 4. You get the same thing in each pair of parentheses, meaning you're factoring correctly. So that 3p plus 4 is a GCF we can take out of both terms. So we'll pull out a 3p plus 4 out of both terms. Now, when you pull out a 3p plus 4 from the first term, you're left with 3p. And when you pull out a 3p plus 4 from the second term, you're left with -5. So 3p plus 4 times 3p minus 5 is your final answer. To check your answer, just multiply your everything out and see if you get the original problem. The next question, and by the way, I'm going over factoring by grouping because it will help us factor trinomials. The last example to the right, again, we got 4 terms, so let's factor by grouping. Group the first 2 terms and the last 2 terms and pull out each GCF. Starting with the first pair of terms, the only thing we can pull out is just an R. So when we take an R out of each of the first 2 terms, what remains is R minus 3. Before we pull out the GCF among the last 2 terms, look at the last term sign. It's positive, but we need it to be a negative sign to match the sign in our parentheses. So that means we need to pull out a negative GCF. Well, at first, it doesn't look like -r plus 3 has anything in common. But remember, by default, you can always divide by 1, or in this case, -1. So when we pull out a -1, -r divided by -1 is a positive r, and a positive 3 divided by -1 is -3. Again, we got the same binomial in each pair of parentheses. Let's take out the r minus 3 from both terms. Now, when we pull an r minus 3 out of the first term, you're left with just r. And when you take out an r minus 3 from the last term, what's left is -1. Final answer is r minus 3 times r minus 1. So that is factoring by grouping. Now, we're going to use factoring by grouping to help us factor trinomials. A trinomial is in the following form: ax squared plus or minus b times x plus or minus c, in which a is greater than 0, or the leading coefficient has to be positive. Here are the steps on how to factor a trinomial. Step 1, and this applies to all factoring, even if you're factoring a binomial or four-term polynomial, always look for a GCF. If there is a GCF, take it out of all three terms before you go to step 2. If there's no GCF, then proceed immediately to step 2. Step 2, multiply A and C, or in other words, multiply your outer numbers. Step 3, you ask yourself, what factors of A times C will give you B in the middle? In other words, what factors of A times C, or your outer terms, will add or subtract to give you your middle term B? Step 4, rewrite the middle term using the factors you found in step 3. And the last step, and this is why I spent so much time on this method, the last step is factor by grouping. All right, for this first trinomial, there is no GCF among the three terms. So let's proceed to step 2. Step 2 says multiply your outside numbers. In this case, 5 times 6. So 5 times 6 gives us a positive 30. Step 3, what factors of A times C, or for this problem, what factors of 30 will somehow add or subtract to give you B, or the middle term, which is -17. Now, -5 and -6 will not work because that gives you -11 when you add them together. So let's take those off right away. Um, 3 and 10, -3 and -10, close, but that doesn't give us -17. Let's try -2 and -15. Now your signs have to be correct also. Let's check the multiplication first. A negative 15 times negative 2 is a positive 30. And then a negative 15 plus a negative 2 gives us negative 17. So we found the right factors. Step 4, rewrite the middle term using the factors you found in step 3. So in no particular order, we can rewrite the negative 17x as negative 15x and negative 2x. And I just brought down the other terms. The last step, factor by grouping. So we'll group the first two terms and the last two terms and take out each pair's GCF. The first two terms, starting with the numbers, both 5 and 15 are divisible by 5. And among the common x's, remember you pull out the smallest exponent to get a GCF. So that is 5x. Now we must write what's left over in parentheses. What's left is x minus 3. And again, to get that information, just simply divide each term by your GCF. So here, 5 can go into itself one time. And if we take away an x from x squared, we're left with an x. Negative 15 divided by 5 is negative 3. And the x's cancel. Moving to the last two terms, look at the sign of your last term. It is positive, but we need it negative to match the sign in the parentheses. So that means to us, take out a negative GCF, or in this case, a negative 2. And don't forget, when you pull out a negative GCF, the sign for each term will change to its opposite. So a negative 2x divided by negative 2 is just x. And a positive 6 divided by negative 2 is a negative 3. Now, this is a great sign that you got the same expression in both pair of parentheses. That means you're factoring correctly. So we'll pull out the x minus 3. Now, when we pull out the x minus 3 from both terms, what's left is 5x minus 2. So this is your final answer factored completely. Again, to check your answer, just multiply everything out and see if you got the original problem. Let me pull up another example and we'll work it out. Give me just a second. Let's leave our steps up here so we can use them. Let's see, hold on just a second. Let me copy and paste another one. All right, we have P as in Paul, P cubed minus 8P squared minus 20P to the first power. First step, look for a GCF. Actually, there is one for this problem. All three terms have at least the letter P in common. So let's take that out. And we're left with P squared minus 8P minus 20. Proceed to step 2. Multiply A and C, or multiply your outer numbers. Well, this leading coefficient is understood to be 1. So 1 times negative 20 is still negative 20. Step 3, what factors of negative 20 will add or subtract to give you the middle term, negative 8? Through trial and error, we know that negative 5 and 4 does not work. That gives us negative 1. Let's see, negative 10 and positive 2. Let's check. A negative 10 times 2 gives you negative 20. And negative 10 plus 2 gives you negative 8. So we got the right combination of factors. Step 4, rewrite the middle term using the factors we found in step 3. So bring down everything and rewrite negative 8P as, in no particular order, negative 10P plus 2P. Last step, factor by grouping. So we'll group the first two terms and the last two terms and take out each GCF. Now the first two terms, and I'm bringing down the GCF P that we pulled out in the very beginning. The first two terms have a P in common. Now when we pull out the letter P from the first two terms, what remains is P minus 10. Second pair of terms, and by the way, we don't need to change the sign of our last term because it is negative and that matches the sign in our parentheses. So we'll just pull out a plus 2. And when we pull out a 2 out of the last two terms, that also gives us P minus 10. P minus 10, we can pull that out of both terms. Now, when we pull out the P minus 10 out of both terms, what remains is P plus 2. And that very first letter P, our GCF that we pulled out at the beginning, don't forget it. It's part of your final answer as well. All right, let's look at another trinomial. And give me 1 second to find one. Okay, here's our next trinomial. Uh-oh, wait a minute. Sorry. Just having a little trouble copying and pasting. Okay, here we go. Sorry for the delay. We want to factor this trinomial. There's no GCF to pull out, so the next step is multiply your outer numbers. For this problem, it's 2 times negative 45. And that gives us negative 90. Now we need to figure out what factors of negative 90 will somehow add or subtract to give us negative 27 in the middle. Through much trial and error, it'll take you a few minutes, but you'll eventually get the right pair of factors. The correct pair of factors is negative 30 and positive 3. Negative 30 times 3 is negative 90. And negative 30 plus 3 is negative 27. The next step, take these factors and use it to rewrite the middle term. So we have negative 30n plus 3n, and we'll just bring down the other terms. The last step is factor by grouping. So we will group the first two terms and the last two terms and pull out their respective GCFs. The first pair of terms, they have a 2 in common. And remember, among common letters, you take out the smallest exponent, which is 1 or just n. Write what's left over in parentheses. And again, not required, but a simple way to figure out what's left over is divide each term by your GCF. So we're left with n minus 15. Now the sign of our last term is negative, so we don't need to change it. The last two terms have a 3 in common, positive 3. And when we pull out a 3 out of both terms, we're left with, no surprise, n minus 15. Now let me say this. When you're rewriting your middle term using your factors, if you put the 3 in first and then negative 30 in, you're correct. Your binomials will be reversed, but your answer will be just as correct as mine. So our final answer here is n minus 15 times 2n plus 3. Let's look at one more trinomial. And give me just a second. Let me find one. Okay, found one. First step, pull out a GCF if there is one. And for this problem, all three terms have a 2 in common. So let's take that out first. And we're left with 3u squared minus 23u minus 8. Now move on to the next step. Multiply your outer numbers. In this case, 3 times negative 8. And that gives us negative 24. Our next step, figure out the factors to negative 24 that will somehow add or subtract to give us a negative 23 in the middle. Through trial and error, you'll come up with the factors negative 24 and positive 1. Now, our next step is to rewrite the middle term using the negative 24 and 1. So that would be negative 24u plus 1u. And we'll bring down the rest of the problem. The last step is factor by grouping. So we'll group the first two terms and the last two terms and pull out their GCFs. The first two terms have a 3 in common as well as a u. Now, what's left in parentheses once we've taken out the 3u is u minus 8. Now, we don't need to change the sign of our last term because it's negative, which matches the sign in our parentheses. By default, if there's nothing else you can pull out as far as a GCF goes, all your terms are at least divisible by 1. So we'll take out a plus 1, which really doesn't change anything. That's still u minus 8. We're ready to put everything together and get our final answer. Don't forget that 2 that you pulled out earlier, put it in front. So our final answer is 2 times u minus 8 times 3u plus 1. Next topic I want to go over from both lessons 13 and 14 is something called special products. The first one is called a perfect square trinomial. And you don't factor it like you do a regular trinomial. I'm going to show you a simple way to factor a perfect square trinomial. Let's say we have the trinomial 16w squared minus 40w plus 25. You don't have to do your 5 steps. Here's a shortcut. If your first number and your last number are perfect square roots, then this is a perfect square trinomial. Keep in mind the square root of 16 is 4, and the square root of 25 is 5. Draw your 2 parentheses. What goes in the first 2 spots is the square root of 16, which is a 4w and 4w. And what goes in the last 2 spots is the square root of 25. So we got a 5 here and a 5 here. MyMathLab, when you have duplicate bases, MyMathLab wants you to express your answer with a single exponent. So since we got 2 of these binomials, we can write them as 4w minus 5 quantity squared. Let's look at another question. We have 9x squared plus, I'll figure out the middle term in just a second, plus 49, and the middle term is plus 42x. Before you perform your 5 steps, look at your first number and your last number. If your first and last number are perfect square roots, then you can use a shortcut. Square root of 9 is 3, and the square root of 49 is 7. This is a perfect square trinomial. Draw your 2 parentheses. What goes in the first 2 spots is the square root of 9. So that will be 3 along with x. What goes in the last 2 spots, square root of 49, or just 7. So we got 7 and 7. Our final answer, because we got 2 of the same base, is parentheses 3x plus 7 quantity squared. So that's how you factor a perfect square trinomial. Another special product is called a difference of 2 squares. Hold on just a second. My battery on my laptop is getting very low, so let me plug in my charger. Hold on just a second. This is still special products that we're about to go over. And difference of two squares actually has its own formula. So I'll write down the formula in just a second. Once I've plugged in my charger. All right, this is the general format for a difference of two squares. A squared minus b squared is a difference of two squares. And to break it down, you draw your two parentheses. A difference of two squares means you have a difference in signs. So we have a plus b times a minus b. Now, a and b have to be perfect square roots, like the perfect square trinomial. If you do not have a perfect square root, like say 17, then you cannot factor. Start with this first one. 25x squared minus 36y squared. This is a difference of two squares because both 25 and 36 are perfect square roots. We have a binomial and we have a difference. So draw your two parentheses, plus and minus. What goes in the first two spots is the square root of 25. That's 5x and 5x. And what goes in the last two spots is the square root of 36, and that is 6y and 6y. And that's all there is to it. Let's look at another problem. Second question, we have 9c squared minus 729. Regardless of the type of, regardless of what you are factoring, always check for a GCF. Actually, both terms are divisible by 9. So when we factor out a 9, we're left with c squared minus 81. That too is a difference of two squares. So we can draw our parentheses and factor. So when we draw two parentheses and factor, what goes in the first two spots is how you evenly break down or split up c squared. So that's just c. And what goes in the last two spots is the square root of 81. That gives you 9 and 9. And your answer is factored completely. Let's look at this next problem. We have x squared minus 61 Although we have a difference and a binomial, we cannot factor this because 61 is not a perfect square root. So polynomials that cannot be factored are called prime. Uh, Last problem here. We have 121c squared plus 100. Now, before you start breaking down this problem, let's check everything. Yeah, true enough, we have perfect square roots, 121 and 100. And yes, we have a binomial, but we do not have a difference. There is no such thing as sum of two squares. In conclusion, number 4 cannot be factored either. I hope this video helped you or helps you with understanding lesson 13 and part of 14. If you have any questions, always email me or use the Ask My Instructor help tool in my math lab, and I will be glad to help you as always.